Imagine if you could see a massive surge in customer demand before it even happened. What if you could know, with real confidence, the exact hour you're going to need more staff, more resources, more of everything? Well, let's get right into it because today we are unpacking the S13 standard. It's a really key part of a lot of data apprenticeships, and it basically gives you a roadmap for turning raw data into a serious operational advantage.
And we're going to do this by walking through a real-world case study. So picture this. You're a data analyst at a food delivery app we'll call Hungry Now. The operations team comes to you with one single critical question, this one right here. Now, getting this right isn't just about numbers, it's about keeping customers happy and making sure the entire business runs like a well-oiled machine.
And the path to that answer? It's all laid out in the S13 standard. Think of it as a three-step journey. First, we have to mine the data to find patterns nobody's seen before. Then, we use those patterns to forecast what's coming next. And finally, we build a model to really understand what's driving the results. These three pillars, they all work together to tell one complete, powerful story.
Okay, so let's really put ourselves in the role. You're the analyst at Hungry Now, and the pressure is definitely on. If you have too few drivers, orders are late and customers get angry. But if you have too many, you're just burning cash. Your job is to find that perfect balance, that sweet spot, and data is going to be your guide.
Now you might be wondering, why are we focusing so hard on this one standard? Well, here's the deal. The assessors who actually grade these projects say S13 is a super common tripwire for data apprentices. It's so easy to just browse the data instead of really mining it, or to pick a model without being able to justify why. Today, we're going to make sure we don't fall into any of those traps.
Let's get to our first step and see how this all builds up. This is where we put on our detective hats. Seriously, data mining isn't about passively looking at a few charts. It's about actively digging for clues and patterns that are hiding right under the surface.
To put it simply, data mining is how we find the gold in all that data. For a company like Hungry Now, this means we're on the hunt for specific, meaningful patterns that tell us why demand is surging and, just as importantly, when. This is the stuff that's going to shape our entire strategy.
And here's a look at the actual tools we used. With clustering, we didn't just see a blob of customers, we discovered these really distinct groups, like a segment we called the late-night snackers, who were driving those crazy evening peaks. Then, association rules showed us that when these snackers used a promo code, their order sizes got bigger, which meant longer prep times at the restaurant. And finally, outlier detection immediately flagged two specific restaurants that were consistently struggling during these rush hours. See? Actionable clues.
And this tip right here gets to the absolute heart of what good data analysis is. Your data mining has to lead somewhere. It is not enough to say, hey, I found something interesting. You have to be able to say, I found this pattern, and because of it, we changed our staffing, or we investigated this specific problem. That is the huge difference between just browsing and doing real, impactful analysis.
Okay, so now that we've found these amazing clues, like that late-night rush, we can shift gears from discovery to prediction. This is the forecasting phase. This is where we use the past to get a clear look into the future.
You know, building a really solid forecast follows a pretty clear playbook. First, we smoothed out the day-to-day noise in the order data. Then, we did a key technical check using something called a Dickey-Fuller test. All that's doing, really, is making sure the data's core properties, like its average, aren't wildly changing over time, which is a must-have for a lot of these models to work right. After that, we basically had a model showdown, pitting a few different approaches against each other before rigorously testing them to find our champion.
And the winner was SARIMA. It's a really powerful model built for exactly this kind of thing, data that has seasonal patterns. But what's important isn't just the fancy name, it's why we picked it. It was simply the best at understanding that repeating weekly rhythm, those Friday night spikes we found during data mining. It gave us a MAPI, that's mean absolute percentage error, which is just our average error rate, of about 10%. For our purposes, that was accurate enough to start scheduling drivers with a whole lot more confidence.
Answering that first big question, when do we need drivers, led us straight to another, even deeper question. We know when the demand is coming, but what are the specific things that actually predict if an order will be late? This is where we go from forecasting what's coming to modeling what's driving it.
So for this, we had another model showdown. In one corner, you've got Random Forest, which is a total powerhouse known for its amazing performance. And in the other corner, you have Logistic Regression, a much simpler model that is incredibly easy to explain. This really highlights a classic dilemma in data science. Do you want the most accurate answer possible, or do you want the one that's easiest to understand?
In the end, we went with logistic regression. And here's why. Even though the random forest was a tiny bit more accurate, we couldn't easily explain how it was making its decisions to the ops team. The logistic model, on the other hand, gave us these crystal clear insights. We could literally say, for every one extra driver we have online, the probability of a late order goes down by X%. That is something the team can understand and act on right away.
And this brings us to the most critical part of this whole process, actually making it count. I mean, all the mining, forecasting, and modeling in the world is totally useless if it doesn't lead to a real change in the business. This is where the rubber meets the road.
Our analysis gives us this super clear 3-step action plan. First, based on that SARIMA forecast, we added 6 more drivers during the weekend rush. Second, based on our outlier detection, we worked directly with those 2 struggling restaurants to help them with their prep times. And third, we set up a system to keep a close eye on everything, making sure our models stayed accurate and that late rates were going down.
So, what happened? Well, the results, they really speak for themselves. The first huge win was a 12% average reduction in delivery times. I mean, just think about that. Across thousands and thousands of orders, customers were getting their food faster, all because we used data to get our staffing right.
And that speed had a direct ripple effect. Faster deliveries mean happier customers, right? We saw a 15% drop in customer complaints during that crucial Friday night peak. That is the tangible, bottom-line business impact we were after from the very beginning.
So, for all of you who are building out your own portfolios, here is exactly how you can talk about a project like this. You want to frame your contributions using these powerful I statements. Notice how each one clearly states the technique you used, why you used it, and what the result was. This is how you show that you've truly mastered the S13 standard.
And that brings us to the end of our Hungry Now story. We went all the way from a kind of vague business problem to concrete actions and incredible results. But you know, in the world of data, the journey never really ends. So I'll leave you with this question to chew on. Now that you have this power to predict demand, what's the next part of the business you would go and revolutionize?